Well, thank you everyone for coming. We're now on schedule for introducing Dr. Todd Osman, who's joining us today to talk a little bit about the material science industry. So Dr. Todd Osman has been the executive director. Executive Director of the Materials Research Society since 2008. As the Executive Director, Dr. Osman works to develop programs addressing critical societal needs, including clean energy, water purification, and science, technology, and engineering and mathematics education, as well as promoting the engagement of all demographics and geographic regions in scientific expertise. Prior to joining MRS, which is Material Research Society, Dr. Osman was instrumental in creating the Pennsylvania Nanomaterials Commercialization Center. He also served as Technical Director for the Minerals, Metals, and Materials Society and spent 11 years at the United States Steel Corporation as a researcher and technical manager. Dr. Osman received his BS, MS, and PhD degrees in Materials Science and Engineering from Case Western Reserve University. So with that, I'd like to welcome Dr. Osman to the podium.
Thank you. This is a little different than a lot of talks I end up giving is, what is material science? I'm assuming that you have a background on that, but I wanted to go over here. Really what I firmly believe and what we try to promote at MRS is materials really are the building block for our future. And there's precedence for that statement and some fact behind it. So we can move on. What is material science? Well, this is quite frankly, in a nutshell, what it is, making stuff. And so appropriately, this is the logo for a NOVA series we just concluded that aired a month ago on PBS on material science. It was making stuff cleaner, making stuff smarter, making stuff stronger, and it went through all the things that material science does. If you go to school today, you don't see material science in the curriculums in chemistry and physics, but material science isn't a discipline, it's a field. You can be trained in any discipline, you can practice materials research. And at its heart, it is what we make stuff from. And what you're going to see, why we need the equipment that's back here. In order to determine how properties, how materials behave, what the properties are, you have to know what their structures, you have to know what they're made of. It's like the little Tinker Toy set, right? Well, on the same level here, you need to know the structure, the properties, and the performance, and the processing. They all go hand in hand to say, how strong would that bridge be? How fast can you drive that car? How well would it survive a crash event? So if I go on to the next slide, I say materials change society. So I made an audacious statement that materials are the foundations for the future. But I'm not going too far out on a limb here, because I have history to back me up here. 3000 BC started bronze smelting. That started the Bronze Age. 1300 BC, Iron Age started. 1755, concrete. We're going to have today's civilization without concrete as a material. 1844, vulcanization of metal, of rubber. You wouldn't have our cars out here. The Bessemer process made steel widespread. We knew about steel, but we couldn't produce it economically until the Bessemer process came around. We have a little bit of a steelhead legacy here in Pittsburgh, thanks to the Bessemer process and Andrew Carnegie bringing it to Pittsburgh. PNN type silicon is discovered, 1936. That's the foundations of our modern electronics and computer age. And now, most recently in 1991, in our brief tour through history here, is carbon nanotubes. Launched the nanotechnology. Everything from stain-resistant pants to hopefully getting materials that are stronger than steel, lighter than steel, and the whole nanotechnology, not Michael Crichton nanotechnology, real nanotechnology. And as I alluded to earlier, it hits home here in Pittsburgh. It's not just how things are formed, it's not something esoteric, it's the basis for a lot of our economy. U.S. Steel, Alcoa, PPG, Bayer, many others. Many other Fortune 500 industries. Many people's livelihoods are based in material science. So it's not just, like I said, an esoteric exercise. We're talking about scientists and engineers talking about how you make materials. It has real life impact. But it goes beyond that. We also have Pittsburgh Steel. So I'm getting down to the most important stuff, right? Named after steel, after material. But I say science will still continue to change society. Many of the critical challenges facing society, if you look at the National Academy of Engineering website, these grand challenges for engineering, almost all of them are related to materials. Energy, you can't have the next generation nuclear power plants, which we will have with the setback in Japan, without new materials. The big components behind nuclear technologies are that you can run higher temperatures, more efficient nuclear reactors. Well, today's generation of materials can't survive in that environment. We need next generation. We have companies in this region investigating the next generation of solar technologies. Can you make the current silicon-based technologies more efficient, less costly? Or can you go the other direction? And there's another company here in Pittsburgh called Flextronics that's using organic ink dot matrix printing to make flexible packaging. Very cheap, not efficient, but if you make it very cheap and you can make a lot of it, and oh, what's another application? Why they're doing it is for our soldiers in the field. You can now print it, roll it up, and they can carry it as their energy source in their backpack. So it goes on tents in the desert to create electricity. Water, medicine, the environment, social infrastructure. I can go on for everything that materials touch and why materials are needed, materials research is needed. But beyond that, it even helps in developing countries. If we want to use science education to develop the standard of living, raise people above the poverty level, materials play a critical role. In this slide, I show here a village in rural Argentina with solar cells on top, bringing electricity that they didn't have before. Solar cookers. One of the most, the biggest source of carbon emissions in Africa is biomass burning. There's a lot of health problems with it too. So can we bring solar cookers now using the heat from the sun to cook food so you don't use as much biomass? And clean water. Clean water everybody needs. Can you use this in a little apparatus called Life Straw? You can actually drink from that water. And I'm saying materials still hold the key on every level, whether it be energy, water purification, nano, not microcrydon as I mentioned, materials for cancer research and medicine, all enabled by nanomaterials and materials in general. So Western PA will still be a nexus, I believe. I hope so. I live here. But well, why? Why? We have an infrastructure for materials science, materials engineering. Fortune 500 companies, entrepreneurs and startup companies, national laboratory and energy, world-class universities, and materials support networks such as Gateway Analytical. You go through this lab back here, is the FTIR, Raman spectroscopy, the scanning electron microscopy, EDS. These are the tools that materials scientists need to develop the next generation of materials. Also, when they're in the field, if something goes wrong, what went wrong? How do we make it better? How do we save people's lives? How do we advance materials to improve the quality of life? So that was my whirlwind tour of why material science is important. I hope you believe in this really quick elevator speech, that it really is the foundation for our future, has relevance to every part of society, whether it be households here and their economy, all the way up to Africa and Latin America and developing countries. Thank you for having me.